Yo. Hey, yo. Hey, what you got there? Hey, come on, man. Hey, you're hogging it all.
Ooh, it's good.
Well, what is it?
This, I've just got some, I've got some dihydrogen monoxide. Would you like some?
What? Are you crazy? What kind of junk are you trying to push on me? Keep that stuff to yourself, junkie. My body's a temple, and I'm not gonna put trash in my temple. I got half a mind to call the cops. What are you trying to do? Kill me?
Well, that'd sort of be hard to do now, wouldn't it?
How dare you?
Okay. Naming binary molecular compounds is a lot like what we did in Chapter 7 when we named some ionic compounds, with just a little bit of a twist. Remember, when we're talking about a binary compound, we mean that there are only two types of elements involved. Let's use this compound as an example, N2O4. How would we name this compound? Just as we did with ionic compounds, the first element in the formula is named first. So therefore, we have nitrogen. We use the entire element name and we don't change the ending of it. And like we did with ionic compounds, the second element is named using its root and then adding the suffix IDE. So this would be oxide. Where we have a difference in molecular compounds and ionic compounds is the use of prefixes. So we indicate the number of each element with a prefix. For example, the prefix for the number 2 is di. So we would say dinitrogen. The prefix for the number 4 is tetra. So in other words, we name this dinitrogen tetroxide. So let's show you the prefixes 1 through 10 because those are going to be the prefixes we use most often. The prefix for 1 is mono. The prefix for 2 is di. The prefix for 3, tri. The prefix for 4 is tetra. The prefix for 5 is penta. The prefix for 6 is hexa. The prefix for 7, hepta. The prefix for 8, octa. The prefix for 9, nona. And the prefix for 10, deca. One important note, we never use the prefix mono on the first element. For example, this formula right here, CO. We wouldn't call this monocarbon monoxide. We only use the mono prefix on the second element. Therefore, this compound is called carbon monoxide. Remember, you can recognize covalent compounds because they'll be composed of nonmetals. You won't have the metal and nonmetal like you do in an ionic compound. So when you see only nonmetals, you'll know that you have to use prefixes in the naming process. Let's try a few examples. Here's one, SF4. What's this one called? Right, sulfur tetrafluoride. Again, not monosulfur because we don't use the mono on the first element. So this is sulfur tetrafluoride. How about this one? P4O10. Right, tetraphosphorus decoxide. You getting the idea? One other thing to note. If your prefix has an A ending, like penta or tetra, and the root of your second element has a vowel ending like oxide, you can just blend those together. We don't say decaoxide, we just say decoxide. What about the one I used at the very beginning with Slim? Did you recognize it? Dihydrogen monoxide. Right, H2O. It's just simply water. So he was freaking out for nothing. For some compounds, though, we don't use the technical rules like this one. We just call it water, don't we? And there's some other compounds that we do this as well. For example, this one. We don't call this nitrogen trihydride. This is actually a common household chemical that we call ammonia. Here's another one that may be more common in the world of chemistry than it is the everyday world, N2H4. We don't call this one dinitrogen tetrahydride. We call this hydrazine. In other words, some molecular compounds have common names and we don't have to use their technical names. When we put some molecules into water, it forms an acidic solution. Acids are very important compounds we're going to talk about a lot more, especially in Chapter 18. A sneak preview though, if a compound produces hydrogen ions in solution, we call that an acid. The two most common types of acids are what we call binary acids and oxy acids. So let's talk about those for a moment. A binary acid contains hydrogen and only one other element. That's it. Binary. Two elements involved, right? And you know that one of them has to be hydrogen. By the way, usually hydrogen will be placed on the front of the formula for an acid. It helps you to know that it's an acid. Here are the rules in naming binary acids. In naming a binary acid, the first word always contains the prefix hydro. Then the root of that first word is the other element that's involved. Finally, you end with the suffix IC. The second word in the name is always acid. So this one, for example, would be hydrochloric acid. Try this one. Hydrobromic acid. Good. So if you see a formula for a compound and you have hydrogen and only one other type of element, you know that it's a binary acid. If you see more than two types of elements, then it's not a binary acid. Let's talk about oxy acids now. What are they, first of all? Well, as you might guess, oxygen is involved. An oxy acid is a combination of hydrogen and an oxyanion. Here's one, for example, HNO3. The first thing we do is we identify the oxyanion that's present. This is where you'll have to use that table of ions. We know not to include hydrogen in this, so it's just NO3, right? That's the oxyanion. NO3 is the nitrate ion. And here's how the naming rules for oxy acids work. If your oxyanion ends in ATE, like this one, then the acid name will end in IC. So this one is simply nitric acid. Remember, it's not a binary. We don't use hydro, do we? So we determine that the oxyanion here is NO3. We find that its name is nitrate, and we know that the acid name has to end in IC. So this is nitric acid. If the oxyanion ends in ITE, like this one, HNO2, the NO2 is the nitrite ion. When you have an oxyanion that ends in ITE, the acid name will have the suffix OUS. So this one is called nitrous acid. Again, there's no hydro in the beginning because this is not a binary. So if you see that there are more than two elements involved in your acid, you know to name it using the oxy acid rules. Let's try another one. Here's HBrO4. We know not to use the hydrogen, so BrO4 is our oxyanion. What's the name of BrO4? Right, perbromate. So we have an ATE ending on perbromate. That means the acid name will end in IC. Therefore, this is perbromic acid. How about this one? HIO. In determining our oxyanion, we just use the IO, not the H. IO is the hypoiodite ion. Okay, so it has an ITE ending. That means that the acid name will end in OUS. So this one's named hypoiodous acid. So when you look at your formula and you see hydrogen on the front, you can know it's probably an acid. And so then you could set about to name it using your rules. Is it a binary acid? Is there only one other element? If so, then you use hydro something ic acid, right? If there are more than two elements involved, it's not a binary. And that means it'll be an oxy acid. In which case you don't use hydro. You look to see which oxyanion is being used as the root, and you name it according to the rules we've discussed. With an oxyanion ending in ATE, having an acid name ending in IC, and then an oxyanion having an ending ITE, having an acid name ending in OUS. Now, we can also work backwards, can't we? If we have a name, we can produce a formula from that. How about this? We have the name diphosphorus trioxide. How would we write that as a formula? Well, we know the prefix di means 2, and the prefix tri means 3. So therefore, we will have P2O3. It's that simple. And we can do the same thing with acids as well. Here's hydroiodic acid. How will we write that as a formula? Well, we see that the prefix hydro is present, which means that it's a binary acid. So therefore we know it's hydrogen and only one other element. In this case, iodine. So therefore the formula is simply HI. What about this one? We have carbonic acid. Notice that there's no hydro on the front. That means it's not a binary, is it? Carbonic acid. Let's work backwards. Remember we said that if the anion has the ending ATE, then the acid name is IC. And if the anion has the ending ITE, then the acid name ends in OUS. This one ends in IC, which means that the anion must end in ATE. So therefore, we're going to look for the carbonate ion. The carbonate ion is CO3, and it has a -2 charge. So hydrogen plus 1, carbonate, -2, we swap and drop, and we get H2CO3. And that's the formula for carbonic acid. So as we're looking at a formula, we first decide if it's an acid or not. If it has the H at the beginning, it's most likely an acid. But if it doesn't, we'll simply name it by using the prefixes as we did earlier in this video. Remembering that we only use the prefix mono on the second element, never on the first. If it is an acid, we look to see if it's a binary acid. Are there only 2 elements involved, one of them being hydrogen? If so, then we know we use the prefix hydro, don't we? Hydro something ic acid. If there's oxygen involved, it's most likely an oxy acid. Then we identify the oxyanion that's present. If the oxyanion has an ATE ending in its name, we use the ending IC for the acid name. And if the oxyanion has the ending ITE in its name, we use the acid ending OUS. Okay, got some homework for you to do. Number 1, write the formula for dinitrogen trioxide. Number 2, write the formula for chloric acid. Number 3, write the name of H2SO4. Notice that there's hydrogen on front. And number 4, write the name of SF6. You can put your answers in the LMS. That's all we're doing in this video. Today we talked about naming molecular compounds. We started out by naming binary compounds using prefixes, and then we talked about how to name acids, binary acids, and oxy acids as well. I hope this video has been helpful to you, but if I can help you in any other way, please let me know. Until next time, God bless. Slim, wait, that's not water.